Here are the three equations. V equals to V naught sin omega t. And the equation of the current is given by I equals to I naught sin omega t plus alpha. In the another one, the current is given by I naught sin omega t minus beta. In case number 1, I have selected two equations, equations 1 and 2. In case number 2, I have selected equation 1 and 3. Here, V naught is nothing but peak value of voltage and I naught is a peak value of current. They are values, they are magnitude, they are numbers. V naught is a number, I naught is a number. Such as V naught equals to 250 volts, V naught value can be 180 volts, V naught value can be 30 volts, and 250 is the magnitude of alternating quantity, 180 is the magnitude, and 30 volt is also magnitude. Similarly, I naught is a value, it is a number, such as I naught equals to 4 amperes, I naught equals to 20 amperes, I naught equals to 5 amperes. So they are the magnitudes of current, the magnitudes of alternating current. Suppose I have one equation V equals to 250 sin omega t and the equation for current I equals to 40 sin omega t plus 30. So what is this 250? This 250 is nothing but peak value of voltage, that is V naught equals to 250. Similarly, what is this 40? 40 nothing but the peak value of current. So I naught equals to 40. In second case, we have V equals to 250 sin omega t and I equals to 40 sin omega t minus 30. In case number 1, we had omega t plus 30. In the case number 2, we have omega t minus 30. So here the peak values are remaining same. That is the peak value of voltage, that is 250 volts, and the peak value of current is 40 amperes. In case number 1, peak value was 250 volt and the peak value of current 40 amperes. But the difference coming here is a plus 30 and in the case number 2 there is a minus 30. What exactly the difference between these two equations? Because at one place it is omega t plus 30, at another place omega t minus 30. One thing is clear, that both the equations are not same. To understand these equations, this variation, this difference, let us first study these three waveform diagrams. Here I got two diagrams. They are sinusoidal diagram. They are called waveforms. One is for voltage, another for current. The diagram corresponding to voltage is called voltage waveform and the diagram corresponding to current is called current waveform. These both the diagrams are in phase. Why they are in phase? Because you see they start with the same instant of time, they end at the same instant of time. There is no time lag between them. Therefore, the voltage waveform and current waveform are moving one along with another. There is no time lag between them. So we say both the diagrams are in phase. In this diagram, both voltage and current are in phase. If two diagrams, that is waveforms, voltage waveform and current waveform, if two diagrams attain their maximum and minimum at same instant of time, then we say both are in phase. If they are in phase, then they reach their zero values, peak values and valley points at the same instant of time. In example 2, I have selected two waveforms here, voltage waveform and current waveform. We observe that when the voltage waveform is maximum, the current waveform is zero. We say the voltage is leading and current is lagging. Let us see the same waveform once again in slow motion. Here we have voltage waveform and current waveform. We observe that the voltage is 0 when the current is maximum. So this diagram corresponding to current is leading and voltage is lagging. What is the reason? The reason is when current is maximum, the voltage value is 0. Let us see the same diagram in slow motion. About discussion, let us summarize here in figure 1, figure 2 and figure 3. In figure 1, voltage and current are in phase. Since they are in phase, therefore they are expressed by the same equation, that is V equals to V naught sin omega t and I equals to I naught sin omega t. What is V naught? V naught is the peak value of the voltage. So this is the peak value of voltage. And what is I naught? I naught is nothing but the peak value of current. This is peak value of current, that is I naught. And here we have written omega t only. There is nothing after omega t. That is here only omega t. Here also only omega t. So when both the expression, both the trigonometry terms are same to same, then we say the current and voltage are in phase. In figure 2, current is lagging by an angle of alpha. You see here I have shown alpha. The difference between both the graphs is alpha. So the current graph is starting as soon as the voltage attains its maximum. So as soon as the voltage attains its maximum, that instant the current is starting. So current is starting after an angle of alpha, omega t minus alpha. Therefore, here current is lagging. So therefore the equation of the current is given by I equals to I naught, and there is omega t minus alpha because there is a lagging angle of alpha. So sin omega t minus alpha. And in the third case, the current is attaining its maximum value. That instant the value of voltage is 0. So as the voltage is 0, the current is maximum. At the instant of current is maximum, the voltage value is 0. So current is leading by how much? By the value of beta. Therefore the expression for current is given by I equals to I naught sin omega t plus beta. The leading and lagging and the peak values can be shown by some rotating vectors called as a phasor diagram. This is a rotating vector. When we had the case 1 and case 2, what was the case 1? V equals to 250 sin omega t and I equals to 40 sin omega t plus 30. Now we need to draw the phasor diagram for this. For that, we have to assume here are the 250 volts. So let us take 10 volt equals to 1 centimeter. We need to draw this line. And so we need to 250 volts can be drawn a length of 25 centimeters. So by and making an angle of omega t in anti-clockwise direction. So and this value here, this value will corresponding to maximum value, that is V naught, and V naught equals to how much? V naught equals to 250 volts. So this diagram we have drawn here. So diagram OA, the diagram OA stand for phasor diagram for voltage. Now after drawing that one, we need to draw the phasor diagram for current. And current is how much? 40 amperes. And we have 10 amperes equals to 10 ampere equals to 1 centimeter, then 40 amperes can be drawn with the length of 4 centimeters. So now phasor diagram for current, we have to draw a line of 4 centimeters. So we have drawn a line of 4 centimeter here. OB is a line of 4 centimeter. And what is the angle? Angle from voltage vector is 30 degrees. 30 degree away from voltage. So the total angle equals to omega t plus 30 degree. And here, if you draw the projection, then it gives the I naught. So OA stand for voltage, phasor of voltage, and OB stand for the phasor of current. Altogether, it is called phasor diagram for current and voltage. Here is an example. V equals to 100 sin omega t and I equals to 20 sin omega t. We need to draw the phasor diagram for this. So first of all, draw the x-axis and y-axis, and V naught value is 100 volts. So let us take some scale, suitable scale, like 20 volts equals to 1 centimeter. So first of all, and both are in phase because both having same trigonometrical function, and voltage is 100 volts. So we draw the 5 centimeter line here. This is stand for V. And now current is 20 amperes. So 20 amperes we can take as a 1 centimeter. On the same vector line of voltage, we draw the another line. This is a line, and this stand for current. Now if you draw the projection, it will give the V naught and it gives the I naught value. V naught value nothing but 100 volts and I naught value nothing but 20 amperes. And this angle is omega t. This is phasor diagram for this given example. Example 2 here, V equals to 200 sin omega t and I equals to 50 sin omega t minus pi by 2. Then how to draw the phasor diagram? First of all, x-axis and y-axis like this, and we have the V naught value, that is 200 volts. So take 25 volts equals to 1 centimeter. Then 200 volts is there, V naught 200 volts. So we need to draw a line of 8 centimeters. So I draw here the line for V naught. Let us say OA, vector OA, that stand for 200 volts. So this stand for 200 volts. We have drawn the phasor diagram for voltage. Now left is current. The current is 50 amperes. We have taken 125 amperes equals to 1 centimeter. Therefore 50 ampere equals to 2 centimeters. And how much? It is omega t minus pi by 2. So it is minus pi by 2. It will come in the downward direction like this. And what is the length? Length is the 2 centimeters, and this will represent 50 amperes, and this angle equals to pi by 2. So this is a phasor diagram for this example. Suppose the current, that is I equals to 50 sin omega t plus pi by 2 is given. Suppose instead of minus, suppose plus is given. Then how you will draw the diagram? The diagram is, everything will remain the same. Here instead of, we cancel this one, we will not draw this one, but we will be drawing plus pi by 2. That means in the anti-clockwise direction, 90 degrees away. So this angle is 90 degree, and this again the 2 centimeters. So the line will shift from here to here, and this will also go away, and this will stand for the I naught. The vector will shift. So this would be the diagram if 50 sin omega t plus pi by 2 is given.